Hello everyone, myself Madhuri and sharing virtual dias with Hitisha. So we are working with John Deere and we would like to share a poster on nanofluids, next generation efficient energy saving solution. Coming to the introduction, in the paint shops, we generally utilize water extensively in the hot water generators to transfer heat from one medium to another medium through indirect heating process. This process consumes more energy to heat water because water is less viscous and has lower thermal conductivity compared to other fluids. Thermal conductivity is nothing but ability of material to conduct or transfer the heat from one material to another medium. In the same way, the water is extensively used for transferring the heat because water is readily available, cheap, and possesses less thermal conductivity and chemical properties. Our problem statement is to increase the rate of heat transfer and at the same time to reduce the energy consumptions. To overcome the disadvantages with the water, we came up with the nanofluids. Nanofluids are empowered with nanoparticles of nanometer size which are used to increase the rate of heat transfer as the number of nanoparticles present in the base fluid, which is water, are more due to which it absorbs heat quickly and recirculate back due to density changes, and which also transfers the heat between different layers of the fluid easily. So coming to the working principle, the heat is transferred from one medium to another medium through convection principle. So during this process, particles adhere to hot surface due to no slip flow condition where the molecule stays for a while on the surface and absorbs heat from the surface and transfer the heat to the other layers within the fluid. In this way, the heat is transferred between the different layers within the fluid. Now, Hitisha will take you through the experiments and the solution.
Thank you, Madhuri. Based on the same working principle, we proposed a solution which is a mixture of nanofluid and water. Due to nanofluid, there is increase in the number of molecules in the mixture which tends to absorb the heat more quickly compared to the water. These molecules recirculate in a faster way due to density difference, which increases the rate of heat transfer within different layers of the fluid or mixture. As there is more absorption and lesser losses, the desired temperature is reached faster compared to the system running only on water. As desired temperature is reached quickly, system cutoff will happen more frequently, thereby reducing energy consumption to run the system. To demonstrate this, we conducted a frugal experiment. I would request Madhuri to share the video of the experiment. You can play the video. So for this experiment, we had two test tubes, one which had a mixture of nanofluid and water, and the other had only water. We started heating both the test tubes using indirect heating method, and we kept a tab on the readings of temperature versus time. So when we started the experiment, both the test tubes were at the room temperature 29.5 degrees Celsius. After heating for around 2 minutes, Hydromax reaches 36.6 degrees Celsius and water reaches 35.1 degrees Celsius. And we continue the heating process, and at around end of 7 minutes, Hydromax has reached 41.1 degrees Celsius and water achieved 43.8 degrees Celsius. So we continued the heating process. We continued to observe the heating and cooling process for around 30 minutes, and we plotted heating and cooling graphs. So coming to the heating graph, you can see the orange color line indicates the Hydromax line, whereas the blue line indicates the water line. After 30 minutes of heating, Hydromax test tube reaches 107.6 degrees Celsius and water has reached 89.6 degrees Celsius. And a similar behavior was observed in cooling graph. Green line indicates Hydromax, whereas blue indicates water. Hydromax had reached 36.1 degrees Celsius after 30 minutes, and water reached 28.8 degrees Celsius. So you can see that Hydromax, due to its better surface area, it has absorbed more heat, and as a result, it has achieved the desired temperature much sooner than water. And due to the better surface area, it was able to retain the heat absorbed in it for a longer period of time compared to water, which is a desirable condition in for industrial purposes. So now I would request Madhuri to take us through benefit and conclusion.
Yeah. Thank you, Hitisha. So I'll take you through the benefits. So with this solution, we can improve the equipment life, and also we can reduce the maintenance cost as this fluid possesses non-corrosive properties. This is energy efficient solution which also reduces the carbon footprints. This fluid is in non-toxic in nature and also non-flammable, and this is also biodegradable and which reduces the usage of water. So the lifespan of this fluid is 20 years. Coming to the conclusion from this study, we conclude that this fluid is a revolutionary heat transfer fluid that utilizes nanothermo technology, and it uses nanoparticles that are suspended in the stable state, which is used to increase the speed of heat transfer by heating up the fluid and transferring the energy in a shorter amount of time, thereby reducing the significant less energy. Furthermore, Hydromax is a specifically formulated to prevent corrosion, calcification, and algae in the systems. Thank you.
Thank you.